everyone, welcome to this video. In this video, we are going to see how a day in the life of a data scientist or machine learning engineer goes like. So what actually happens in the life of a data scientist or machine learning engineer from the moment you open your laptop to when you finally close it? Not the Instagram version, the real version. Today, I'm pulling back the curtain. So, hey, welcome back. If you are new here, I talk about data careers, machine learning, and how to break into this industry. Today, we are doing a full walkthrough of a typical workday as a DS and ML engineer. The meeting, the code, the chaos, and yes, the moment where your model just refuses to work. So let's get into it. Before we dive into each block, here is a 3,000 or 30,000 foot view of the day. You're looking at roughly 8 a.m. to about 7 p.m. And I want to be real with you. Not every day looks like this. Some days you are deep in data for 6 hours straight. Some days you are in a back-to-back meetings and write zero lines of code. But this structure, it covers 70 to 80% of your week, especially in a product-focused company or tech startup. Five big blocks: morning, planning, data wrangling, model training, stakeholder meeting, and then deployment and code review. So let us walk through each one. All right, so it's 8 a.m. First thing, coffee, obviously, non-negotiable. But seriously, the first thing I actually do is open Slack because overnight your data pipelines have been running. Your models might have thrown alerts, and your teammates in different time zones may have sent messages that need attention. You're checking three things right away. One, did my data pipeline break? Two, are there any model drift alerts? Three, what's on the agenda today? Then comes the sprint planning check. You open Jira or Linear or whatever your team uses and you look at your tickets. What's due? What got overnight? What is blocked? And then the stand up. 15 minutes max. So, what did you do yesterday? What are you doing today? Any blockers? Simple, clean, don't ramble. Pro tip, and this one changed my productivity completely. Block 2 hours of deep work time on your calendar before anyone else can schedule meetings. Protect that time like it is sacred because once your calendar is full of 30-minute sync calls, you'll never get into flow state. Data wrangling and EDA. Okay, so here is the part that nobody tells you about when they are selling you on a data science dream. 80% of your time is data preparation, not model training, not fancy algorithm, data wrangling. You have heard it before, but until you're actually in the job, cleaning the dataset that has 47 columns named feature 1 through feature 47 with no documentation, you don't fully appreciate it. Here's what the typical EDA session looks like in Python. You start with df.info to understand your shape, your data types, your null counts. Then you run describe to get your distributions. You plot the correlation heat map to see what's related to what. Then comes to the fun part or the painful part, depending on your mood: handling missing values, encoding categoricals, dealing with outliers, and engineering new features. For example, if you have a purchase date column, you might extract day of week, time since last purchase, month, is it a holiday? And suddenly you have turned one column into five useful features. This phase is where domain knowledge really shines. If you don't remember, if you don't understand the business context, why this data was collected, what the user journey looks like, you'll build features that are technically correct but practically useless. Model training, 11 a.m. model training. Now we are in the zone. You have got clean data, you have got features, time to build. Here's the pipeline you will follow for almost every project: feature selection, train validation split, baseline model, hyperparameter tuning, and evaluation. Start with the baseline. Always, I cannot stress this enough. Your XGBoost model that took you 2 days to time. If a simple logistic regression gets 85% accuracy and yours gets 87% accuracy, you need to ask, is it 2% worth to add that complexity? Sometimes yes, often no. The secret weapon of a senior data science engineers to experiment tracking. Tools like MLflow or weights and biases lets you log every run, what hyperparameters you use, what metrics you got, what artifacts looks like. You can compare 50 experiments side by side and instantly see what has worked. The models will be training depending on your domain. Grading boosting for tabular data, XGBoost, LightGBM are the workhorses, PyTorch or TensorFlow for deep learning, Hugging Face transformers for anything text related to things, and increasingly fine-tuning large language models for specialized tasks. One honest thing that I'll say, model training isn't always glamorous. Sometimes you're starting at a loss curve that not converging, and you're Googling why my neural network not learning at 11:30 a.m. And that is a real life. 1 p.m. lunch and learning. Take your lunch break. That is not optional. The best data scientists I know are obsessive learners, but they are also intentional about recovery time. Eating at your desk, starting at a notebook is not sustainable. Now, here's something that I've built into my routine that's paid massive dividends. Using lunch to consume content passively. I'm talking archive paper summaries, the Lex Friedman podcast, and Rich Karpathy's YouTube channel. Genius level content in a digestible format. You don't need to read every paper front to back. Learn to scheme abstract, look at the figures, read the conclusion. You're staying aware of what's happening in the field, not writing a PhD thesis. Not writing a PhD thesis. If you are newer to the field and you want to structured learning, fast.ai is generally the best practical deep learning course that exists. Hands down. Deep learning.ai for more structured specializations. Papers with code for seeing the state of the art results with linked implementation. Kaggle is also underrated for this time slot. Browsing winning solutions to past competitions is like getting a master class in feature engineering and model design from people who actually won. Stakeholder meetings, 2 p.m. And this is the blog that makes or breaks data scientists at the mid to senior level. Technical skills get your job. Communication skills get you promoted. And here's the translation challenges you'll face every single day. You have trained a model with an AUC ROC of 0.94 with a five-fold cross-validation and SHAP-based feature importance analysis. You're proud of it. You walk into the meeting and the VP of product just wanted to know, will this save us money? Will this help users? When can we ship it? Your job, and this is genius skill you develop over time, is to translate your technical output into business impact. Don't lead with AUC ROC, lead with this model correctly identifies 90% of at-risk customers, which translate to roughly $2 million in retention saving annually. The other thing that separates a great DS engineers, what is that? Knowing when to push back. If a stakeholder wanted 99% accuracy by next Friday, and you know the dataset has fundamental quality issues, you have to be the person who says respectfully, that's not achievable with the data, but here is what is achievable and why it still valuable. That intellectual courage is rare, and that develop it. You should develop it. 4 p.m. deployment and code review. All right, so we are in the afternoon now. The creative energy of this morning is fading, but this block is where you make your real work. A model that lives in a Jupyter notebook is not a product. It's a science experiment. Deploying it where it becomes something that is practically impact users. So walk through pipeline diagram, the MLOps pipeline, your model goes into a model registry. Think of it like version control for models, then goes through unit test, then the CI/CD pipeline kicks in, automatic checks on every code push, then it is containerized with Docker, then it deployed to Kubernetes or a cloud provider like AWS SageMaker or GCP Vertex AI, and critically monitoring once your model is live. You need dashboards that alerts when data distribution shift, when model accuracy drops, when latency spikes. And this is where Prometheus and Grafana come in. Code review is equally important, but before anything merges to main, someone on your team is checking, is this reproducible? And are there unit tests? Is there data leakage? Are the docstring clears? Is memory usage reasonable? I have seen production incidents caused by tiny things like not setting a random seed or having training data accidentally leak into the validation set. Code review catches this. Do not skip this. Last, skips and salary. Let's talk about money because you deserve clarity here. Entry level junior data scientists you are looking at, they are earning 10 to 12 lakhs per year, depending on location and company size. With 2 to 5 years of experience as a mid level, you're in the 20 to 15 to 20 lakh salary. Senior with 5 plus years of experience, earning 20 to 25 plus lakh salary. And staff and principal level, the folks leading entire data functions, that's 220 or I would say 30 to 40 lakhs and beyond, often with significant equity. And in top tech companies, Google, Meta, Anthropic, OpenAI, this number shifts significantly upward. Compensation at those levels is a much in a stock as it is in a salary. So what you absolutely must have, you should have pandas, Python, NumPy, scikit-learn, SQL. You will store SQL every single day. ML frameworks, PyTorch especially, is dominant right now. Statistics, probability, understanding distribution, hypothesis testing, Bayesian reasoning, and cloud, at least one of AWS, GCP, or Azure. What sets you apart from everyone else right now? LLM and GenAI experience. Knowing how to fine tune, prompt engineer, or build on top of foundation models is a massive differentiator in 2024. MLOps skills and underrated communication. Seriously, being able to explain your code, your work clearly in plain language in more rare than what you would think. And last but not the least, we have, and that's a real day. It's not always glamorous. Some days you feel like a genius when your model converges on the first try. Other days you spend 4 hours debugging a shape mismatch error and discover it was missing dot fit call. But here's what I love about this career. You're solving real world problems data with the data. You're building things that people actually use. And the field is evolving so fast that there's always something new to learn. The journey genuinely does start with one line of code. If you found this valuable, hit that like button. It genuinely helps this video reach more people who are trying to break this into data science. Subscribe if you want more content like this. I post weekly on careers, technical deep dives, and real talk about the industry. You can drop a comment below. What is your biggest challenge right now in your data science journey? Is it the technical skills, breaking into industry, communicating with stakeholders? Let me know. I read every comment and it shapes what I make next. So see you in the next one. Thank you. Happy learning. Take care. Bye.